We will look at question 9 of your mid-year exam paper 2. In the figure, AE is a tangent to the circle, whose center is O. B, C, D, and E are points on the circumference of the circle. ABC is a straight line. BAE is 45 degrees. BOE is 76 degrees. And DCE is 48 degrees. They want us to complete the statements to find the sizes of the different angles and at the same time stating the reasons. For part 1, angle OBE, now we know that OB and OE are the radius of this circle with center O. So we do have triangle BOE, which is an isosceles triangle, and angle OBE is the base of an isosceles triangle. So we can easily find the value of angle OBE. So angle OBE is 52 degrees because it is the base of an isosceles triangle. For part 2, they want us to find the angle ECB. We see that BCE and BOE are actually related by the property angle at center equals to 2 times the angle at the circumference. So the size of angle ECB would simply be 76 divided by 2. Let's go on to part 3. Part 3 wants us to find the size of angle DEB. Which is this angle over here. Now if we look at this diagram, points B, C, D, E are points on the circumference of the circle. So they actually form a cyclic quadrilateral. I have found the size of angle ECB as 38 degrees in part 2. So if I want to find the size of angle DEB, I can simply take 180 minus away the total value of these two angles, and that would give me the size of angle DEB. So I write down the reason: opposite angles in a cyclic quad, or it's also the same as angles in opposite segments. If I were to use DB as my chord, I see that the two angles here and here, angles in opposite segment, they should add up to 180 degrees. So this is my answer for part A. Now let's go on to look at part B. Part B wants us to calculate angle OBA. Which is this angle here, angle OBA. So let's take a look at a few possible ways that we can actually solve for this angle. I can make use of my quadrilateral OBAE. So in quadrilateral OBAE, just outline it out. I know 76, I know 45, and I'll be able to find this angle OEA as 90 degrees because tangent is perpendicular to the radius. Then I can make use of the sum of angles in a quadrilateral to find what I want to find, angle OBA. So I'll first write down angle OEA is 90 degrees. And then I'll use the sum of angles in a quadrilateral, which is 360 degrees, minus of the sum of the other angles, to give me my answer, 149 degrees. Alternatively, you might not want to use the quadrilateral. You can also make use of triangle BEA,